Cosmology is the branch of physics and astronomy dealing with how the cosmos or universe was formed and its chronology since. Big Bang Theory. This theory suggests the universe began as a singularity, where all matter and energy in the universe were concentrated in a single point. This single point then underwent a rapid expansion about 14 billion years ago. As the expansion progressed, the original high-energy state began to cool, and fundamental particles began to form the elements in the periodic table. Cosmic microwave background, CMB. This is a faint record of radiation that is thought to be a remnant of the Big Bang. As such, it provides evidence for a hot, dense beginning. Expanding universe. In 1927, George Lemaitre proposed a theory that a primeval atom was the starting place of an expanding universe. In 1928, Edwin Hubble observed a red shift or Doppler effect in all distant galaxies. The farther away the galaxy is, the greater the redshift. This observation suggests that the fabric of the entire universe is expanding. These ideas and observations became key support pieces for the Big Bang Theory. There are some interesting constant values of cosmological phenomenon: speed of light, gravitational attraction, Planck constant of blackbody radiation, fine structured constant of atomic spectra, Hubble constant of expansion, cosmic microwave background, CMB, temperature. Changes to these constants would result in a very different universe. Gravitational attraction, either smaller or larger, would substantially change the formation of stars and galaxies. Planck constant of blackbody radiation would change the formation of fundamental particles and stable nuclei of atoms. Fine structured constant of atomic spectra would change electromagnetic interactions of atoms and molecules, with ripples across chemistry and how life was formed. Hubble constant of expansion, the universe could be either younger or older, changing how elements formed into fundamental structures. Cosmic microwave background, CMB, temperature, changing the balance of energy and matter and how elements were formed. Structural formation. Given the constants we observe, cosmologists can create models of how stars and galaxies were formed over time. First, they postulate initial density fluctuations in the state of energy and matter. Then, they calculate how gravitational force was balanced against expansion. They develop a hierarchy to explain how smaller structures like atomic elements combined into more complex forms, and then how those forms merge to create stars and galaxies. The fundamental nature of time and space play a basic role. We think time and space were compacted at the origin, Big Bang. We think time and space are connected. We think time and space are expanding. We think time is linear, it moves in only one direction. It's important to note that we know very little about time and space. It can be more illuminating to note what we don't know about time and space. don't understand how anything could exist before the beginning, Big Bang. We don't understand why time appears to be linear and moves in only one direction. We know that time and space correlate, but don't really understand how that works. We don't know if time has more than one dimension, or if space has more than 3 dimensions. We don't know how or why time and space seem to be expanding. Alternative cosmologies. There are many theories of cosmology that attempt to explain how the universe began, what came before the Big Bang, and how it may end. Some of these postulate a cycle of expansion and reduction. Some of them involve modifying the constants. Some of them involve multiple or parallel universes. Multiverse theory. String theory with its multiple dimensions can postulate multiple universes. In some models of multiple universes, the constants may differ, creating different pathways to form fundamental structures. This could create many pocket universes, each with their own rules of physics. Different fundamentals could make it difficult to observe or confirm other universes. This leaves us wondering about 2 questions. How fragile is our current universe? Is it possible to create a designer pocket universe?